Hello, we're going to look at the topic of alkanes in this video. We're going to look at what they are, how to name them, how to draw them, and different types of formula for alkanes. Then we're going to look at isomers and what that means and how to draw different isomers. And then we're going to finish with looking at some of the reactions of alkanes, and one in particular, which is the reaction with halogens. So the first thing to look at with alkanes is recognizing that alkanes are a family of hydrocarbons, and it's really important that you know what a hydrocarbon means. And the clue is a little bit in the name. A hydrocarbon is a compound made only of hydrogen and carbon. I'm going to emphasize only, because it's really important that you put that in your answer. There's only hydrogen and carbon. And just to give you a little example, I'm going to draw another type of compound. And if you look at this, it's one carbon, and it's got 4 hydrogens in total and 1 oxygen. So this is not a hydrocarbon because it contains an oxygen, so it cannot be a hydrocarbon. So you get simple questions that say which of these is not a hydrocarbon. Find the one that has an element that's not a hydrogen and carbon, and it's as straightforward as that. So a hydrocarbon compound made of only hydrogen and carbon atoms, nothing else. Right, so now we know what a hydrocarbon is, we can start to look at the alkane family in a little bit more detail. So we're going to look at how to name the first 5 alkanes. And alkanes are named based on how many carbon atoms there are in the molecule. So if you look at the list here, we've got 1 carbon, 2 carbons, 3, 4, 5. And if you look at the names, the first carbon, when it's only got first molecule when it's only got 1 carbon, is called methane. And methane has a formula of CH4, so that's its molecular formula. Ethane, 2 carbons, propane, 3 carbons, butane, 4 carbons, pentane, 5 carbons. One way of remembering the first 4 is a little rhyme, which is monkeys eat peeled bananas. And that's just a really quick way of remembering that the first one is M for methane, E for 2, ethane, P, propane, and 4 is B, or bananas. So methane, ethane, propane, butane. And then after 4, you just use the same naming as you would in maths. So a 5-sided shape is a pentagon. Hydrocarbon with 5 carbons is pent. Notice the ending for all of these is ANE, 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 ANE. And that's the same for all alkanes. They always end in ane because they're all alkanes. So methane, ethane, propane, butane, and pentane. And that's how we name first 5. And you can go on. So 6, hexane, 7, heptane, 8, octane, and so on. Right, in organic chemistry, which is what we're looking at today, there are lots and lots of different types of formula. And so we've been looking at alkanes in particular, and we're going to use that as our example to talk about different types of formula. So the first type of formula, and the one you're probably most familiar with, is called the molecular formula. And that simply lists how many of each type of atom. So the one I've given you here is C4H10, or from the previous slide, butane, because it's got 4 carbons. And when we write the molecular formula, you write C, little 4, because there's 4 carbons, H, 10, because there are 10 hydrogens, atoms joining to the carbons. The next type of formula, a little bit more complicated, is what we call the empirical formula. And that, a little bit wordy, but it's the simplest whole number ratio of each element in a compound. In simple terms, can I simplify the molecular formula? So C4H10 can be simplified by dividing by 2 to C2H5, and that's the simplest whole number ratio that I can give of that particular formula. So it's not the actual number of carbons, it's just a simplified ratio. Right, the next one, and we use this quite a lot in organic chemistry, is what we call the displayed formula. And I'm going to give you the example of butane that we've just used. So the displayed formula is when you show each and every atom and you show each and every bond that joins each atom together. So I've got 4 carbons, and you tend to join the carbons together because carbon can form 4 bonds. And then to each carbon, I'm going to add the right number of bonds, and the carbon forms always 4 bonds. So it's always got 4 lines coming off it, and I'm just going to add hydrogens to those bonds. And hydrogens can only ever form 1 bond, so these lines represent bonds. And when you do a little bit more chemistry, you realize they are covalent bonds. So we've done the molecular formula for this compound. It's C4H10. We've simplified that, so it's the empirical formula, which is C2H5. Then we've got what's called the displayed formula, which is the one I've just drawn on the screen, and that shows every single atom and every single bond. And then the last one I've mentioned here is structural formula, and that's just an abbreviated way of showing the displayed formula. So what you do is you look at each carbon in turn. So I'm going to write that C, and you write down what's bonded to that carbon. So there are 1, 2, 3 hydrogens. So I'm going to write CH3. Then I'm going across to the next carbon. I'm going to write C, and it's got 2 hydrogens attached. 2. Then I go across to the next carbon, C, and it's got 2 hydrogens. And then finally, on the end carbon, I've got carbon, and I've got 3 hydrogens joined to that. So the structural formula is linked to the displayed formula, but it's just a condensed version of that. So we've looked at lots of different types of formula, but we've missed one of the formulas, which is called the general formula. And alkanes will all have the same general formula. So if we just start thinking about what some of the first few formulas were, we had CH4, we had C2H6, we had C3H8, and we had C4H10. So methane, ethane, propane, and butane. If you look at them, there is a pattern to the number of carbons and hydrogens that they have. And I could get you to work it out, but I'm going to show it for you. The general formula for alkanes, and this is something you really should learn, is CnH2n plus 2. And N is the number of carbons in the chain. So just to give you an example, when N is 5 rather, so let's put 5, we'll put H. So what's 2 times N? 2 times 5 is 10, plus 2 is 12. And if you have to look back, that is the molecular formula for pentane. And you can use this formula to work out the molecular formula for any alkane. So it will always be CnH2n plus 2. So all alkanes follow this general formula. So now you know what a molecular formula is, and you should know what a displayed and a structural formula are. We're going to talk about isomers. Isomers are a really common source of exam questions. So you need to learn this definition. So isomers have the same molecular formula, but different displayed or structural formula. Either of those is fine. I'm going to use butane again as my example, and I'm going to draw it. So firstly, I should give you the molecular formulas, which is C4H10. So we said an isomer is the same molecular formula, but it will be drawn or displayed in a different way. So the easiest way to do it first is the one on the previous page, which was do a straight chain isomer, so C4H10. So that is one way of drawing the displayed formula of butane. But I can do it in a slightly different arrangement. And you actually have to physically move the carbons. So you can't just bend them. So I'll show you another example. C, C, C. But this time, instead of having 4 carbons in a row, I'm going to put one in the middle. And then to those, I'm going to add the hydrogens. Might get a little bit messy. And there we go. So that is another perfectly acceptable way of drawing butane. But it's different from the first one. So it's an isomer, has the same molecular formula, still C4, 4 carbons, still 10 hydrogens. Just to identify some bits that people often get wrong. And sometimes we see this. So you do carbon like that. I haven't joined my hydrogens just for space. All I've done in this particular one is exactly the same as that one. So I've just bent the carbon around the corner. You actually have to physically break the carbon bond and put it in a different place for it to be a new isomer. So that's something just to bear in mind. You can't just bend it in different ways. You have to break bonds in the compound. Right, another term you're going to come across when we look at alkanes is the term saturated. So the question would be, are alkanes saturated hydrocarbons? So we already know hydrocarbons are compounds with only hydrogen and carbon. But what's this term saturated mean? So if you were paying attention to the previous slides, you'll have noticed that all of the carbon atoms were joined with a single bond between them. So there was a single line between each carbon atom. And that's how we define what a saturated hydrocarbon is. It's a hydrocarbon with only single carbon-carbon bonds. So if I just illustrate that, if we were to draw ethane, which has 2 carbons, so that's C2H6. If you notice, between the 2 carbons, it's just joined by a single bond, so a single line. There are other hydrocarbons that have 2 lines or double bonds between them, and they are not saturated. Saturated only have single carbon-carbon bonds. Right, the last thing to look at with alkanes is their reaction with halogens. And if you didn't know already, but the halogens are group 7 in the periodic table. So that's fluorine, chlorine, bromine, and iodine, and so on. Right, halogens will only react with alkanes in the presence of UV light. If it's just happening at room temperature, nothing will happen. They won't react. So they're quite unreactive, but you need UV light to be present for them to react. Now I'm going to write out the displayed formula for this reaction just to show you what it looks like. It's an important reaction. So I'm going to start with methane, which is CH4. So methane. And I'm going to add, in this case I'm going to use bromine. Now the formula for bromine is Br2. Something you learn about the halogens, they always are diatomic. There's always 2 atoms joined in a molecule. Right, so at room temperature, nothing will happen. If you have UV light present, they can react. And all that happens when they react is you get almost the same formula, but one of the hydrogens is replaced with one of the bromines. So it's not just replaced, it's what we call substituted. So it's a substitution reaction because one of the bromines replaces one of the hydrogens. One of the bromines substitutes with one of the hydrogens. So where does the other hydrogen go and what happens to the other bromine? Well, effectively, they pair up. So the hydrogen that was removed now buddies up with the other bromine that didn't add on to make HBr. And it's always going to be the same. One halogen replaces one of the hydrogens. I could easily have done chlorine here and the reaction would have been exactly the same. And just to really emphasize, because they will ask you, what type of reaction is this? It's a substitution reaction because one of the hydrogens is replaced by one of the bromines. In the spec, they say mono substitution, so just one substitution. You can have further substitutions, but we don't need to worry about that.